Okay, hi everybody. My name is Amitai Stern. I'm a software engineer and the team lead of the telemetry storage team at LogzIO. What is LogzIO? Who are we? LogzIO is an observability platform. What we do is we provide lots of observability as a service. Companies basically send all their observability data from logs, metrics, traces. We store those inside OpenSearch today. We used to do it in Elasticsearch. And we provide familiar open source user experience over that. For example, Grafana over your monitoring data, or OpenSearch dashboards after we used to provide Kibana for your log data, Jaeger for traces. Today we're going to talk about upgrading log analytics clusters to OpenSearch. When we started out, everything was Elasticsearch version 6.8, and we wanted to make a huge change and upgrade to something that is still open source. And I'd like to talk first a little bit about that. So raise your hand if you've never heard of Elasticsearch or you don't know what that is. Okay, so someone at the back. So Elasticsearch is a search and analytics suite. It's perfect for throwing in unstructured data at scale and reading it really quickly using Lucene. It's basically, if you want to really dumb it down, it's distributed Lucene, okay? OpenSearch, on the other hand, is not on the other hand. OpenSearch is a fork of Elasticsearch. It's derived from the last open source version. I'd like to talk a bit about what that looks like, what that looked like going from about a year and a half back. So as I said, LogzIO was primarily based on Elasticsearch 6.8. The reason we were there is because it was a really stable version of the open source distribution. Lots of customers were using it, and it was easier for them to just move over to us as manager of their observability data. Another reason we were in 6.8 for a while is because version 7 had such a long breaking changes list. Like it was insane. The release notes went on, and it was very hard to make the change. We had a huge document saying if we want to move over, we're going to have to change this, swap that out, and make all these changes. Around January 2021, Elasticsearch made a huge announcement. They said they're not going to be open source anymore. They're still providing their licensed version, and they're going to provide something called server-side public license, which SSPL, a new kind of license. Everybody loves to hear that, especially lawyers, right? What does that mean, SSPL? Right when they did this announcement, when they made this announcement, companies such as LogzIO and AWS, who relied on Elasticsearch for certain services, they noticed that it's really geared in that SSPL is kind of geared to change things for SaaS companies providing Elasticsearch, so they have to take some action. And what they did is they doubled down on open source, and they decided to fork the project, which is a really huge undertaking. It was about 3.5 million lines of code to fork this. LogzIO also helped out in certain ways, but most of it was spearheaded by AWS. And by July 2021, OpenSearch version 1 was launched. If you look at things kind of on the base level, like you look at historic events, this is kind of what it looks like. However, if you are a lawyer or a SaaS company, this is what it looks like, the same graph. And you were following Apache licensed software, and it just changed from version 7.10 to some other thing with version 1. Whereas there's a fork on the upper side of the slide from open source to this new thing called SSPL. And that's how we viewed it. It's just things changed. We could not use Elasticsearch anymore from that point onward. Other companies also couldn't use it. If you're a DevOps engineer or a FinOps engineer, then you might view things a little bit differently. Like you can't stick around on 6.8 even though it's really, really stable, because version 6.8 of Elasticsearch does not support ARM64 architecture. And I bet everybody's heard of Graviton 2. AWS instances? No, yes. Graviton 2 instances are ARM64 based. And these instance types that AWS was providing right around like summer of 2021, about 15% cheaper and 40% performance boost. So it was really a lucrative thing. I said we really have to change to this ARM64 architecture. And if you want to upgrade, you have to upgrade to version 7.9 onwards in Elasticsearch to enjoy ARM64 compatibility. So you have to upgrade, right? You can't stay in 6.8. You can't go to 7.11. So we can't continue with Elasticsearch. And so the decision was really to jump up to OpenSearch version 1. And mind you, it means we have to take into account all those breaking changes and also what is the diff between Elasticsearch and OpenSearch. So if you see 7.10 and 1 are very compatible. They're almost the same project at the time, minus a few really, really minor differences, but they're really not important for most use cases. It's irrelevant. Did this work? Let's click it again. Oh, delayed. There we go. This is the next slide. Good. A basic log analytics cluster architecture is what you see on the screen right now. We have Elasticsearch in the middle. It's ingesting a lot of data. And the top part is really, I put it in red because it's like much higher throughput. The ingest is very, very fast. Average cluster is between like 5 and 10 terabytes a day. Some a little bit more. In some cases, we got up to 25 terabytes a day. Those are really big clusters, ingesting many millions of logs per second. It goes through Kafka. Log engines are the consumer. They're going to consume the logs, enrich them, do a little bit of transformation, and then do an indexing action into Elasticsearch. We snapshot Elasticsearch clusters into Amazon S3, or if you're in Azure, then into Azure Blob. And then there's the read path. So if you're just doing a search, you're going to go via Kibana. We encapsulate that in our application, and then you use, but we have like a differentiator there, right? a layer of abstraction, which is the query service. It's important when you're doing things multi-tenant to have an extra layer of abstraction to enable that and enforce it. So we have a query service and other microservices. For example, if you want to support reporting, then you have some microservice that's going to scan the data, create a report, and send it off to Slack or something like that. So that's the basic architecture. And when you look at it, you see there's a lot of things kind of focused in on the Elasticsearch part. You can't just switch it with OpenSearch and expect things to be perfectly fine. There's a lot of APIs accessing it. There's a control layer somewhere in the other microservices, making sure the cluster is OK, updating index lifecycle. These things are all managed inside those other microservices, and you can't expect to just switch it out. So you have to prepare for the upgrade. And while preparing, there's a lot of things that really tie down your Elasticsearch cluster, and surprising that they do. So what we did in order to prepare is we started out very simply creating an OpenSearch cluster and seeing what breaks in staging environments. So everything broke, like absolutely everything. So we went back a step and we said, let's try in our test environment, just put it over there, see how many things break, and try to fix them one by one, what's wrong. The breaking changes factor was enormous. And we went through all the breaking changes of Elasticsearch 7 and started solving them one at a time. A lot of deprecations were at the time. So if you think about API changes, OpenSearch is 7. So when you do like get hits from a query, it actually returns an object. So inside the object of get hits, there's hits again with the number of hits. So all our API is used to get a number, and now they're getting this object. So obviously, everything breaks. Other breaking changes, such as, let's think, in the templates, the underscore default mapping, you can't have that anymore. So all our templates were basically broken, and a cluster wouldn't start with all these broken templates. Another thing to look out for is your test environment. You have to think about it when you're preparing for an upgrade, a version upgrade, and this is a question that arises whenever you're upgrading any big part of your architecture. The question is, when do you change it in your test environment? Do you want to switch to OpenSearch before your clusters are on OpenSearch? Well, then you're testing the future, but maybe something's going to break in Elasticsearch now on a live cluster. Do you wait till it's like 50% done? That's hard to do. And if you wait till the end, you have to be certain that you haven't broken the OpenSearch clusters that will be there while developing things that are only tested on Elasticsearch. This is a really hard question to answer, and it's really a use case dependent thing. In our case, it took so long to move from Elasticsearch to OpenSearch. It took months because of the process, learning on the way how to actually perform an upgrade, that we stayed with Elasticsearch until we were almost done, and then we switched to the test environment. But we had a lot of friction there. Like, a lot of things would go in and break the OpenSearch cluster. We had to keep back and forth switching out the test environment. Another thing to look out for is cluster settings. In Elasticsearch, you could change the cluster settings from one version to the next. It won't appear as a breaking change. And that's a big problem. So if you change, for example, how many contexts, there's something called a scroll API. And then there's a number of contexts that can be open at a given moment. In Elasticsearch 6.8, the max is set to the max int. So as many as you want. Open as many scroll contexts as you want. And that's very bad for the cluster, by the way. It just puts an enormous load on it. Elasticsearch 7, the default is 100. So if your users, which are not LogzIO in our case, it's our users that are using the SaaS, are using this feature, hundreds, thousands of, maybe creating 1,000 contexts, then we upgraded to OpenSearch, it would break, right? But it wouldn't break in our test environment because we don't test how many contexts can be open. It's really like an esoteric situation. And it did break, actually. Luckily, very early on, when we did this thing where we created a new cluster in our production environment after we solved most of these issues. And then we got to test the different cluster settings. So it was important to us to have an actual live cluster. We would mirror data into it, which is something I'll talk a little bit more about later. And then we noticed that, OK, in certain cases, this setting is beyond the default. And it would actually break in production, but it wouldn't affect the customers. And that's a really important thing. You create an extra cluster. It's a good way to prepare. Index versions. If you've ever upgraded Elasticsearch, index versions are a real big pain. There's no button to upgrade an index version. The only way to upgrade the index version is to re-index the whole index. So let me talk a little bit about that. The version that you're using has wire compatibility one version back. So we were using version 6.8. If we have an index that was created on version 5 and migrated at the time to version 6, it's still listed as version 5 on an Elasticsearch 6 cluster. You cannot upgrade then to 7. I mean, you can, but it won't start up. Like the node won't even start because it'll detect indices with the wrong version. They're not compatible. And in this case, you have to do the reindexing, and it takes a long time. Like if you have a few gigs, it'll take hours to reindex the index, even on a powerful cluster. So we have to upgrade ahead of time all our indices that were on version 5 to version 6. And if you don't plan for it, you'll be in a situation where you're telling your manager, listen, we need a month now in advance to delay things because we're reindexing the data we already have. Maybe some of you think, oh, I can take it from a snapshot and load it in, and then it'll be faster. But the snapshot saves the version, so you can't actually ever change it. The reason for this is the Lucene underneath the hood. You don't want to change the index version because the Lucene reader won't work. So that's about preparing. Once we're prepared, we want to talk about how what kind of strategies there are. Just the generic ones. I'm going to talk about the two main strategies. There are other ones, but these are the two main ones. Blue-green and in place. Okay? And the way to do blue-green and in place when we're upgrading, there we go, it worked, from Elasticsearch to OpenSearch. Starting with the more common blue-green. So what we see here, we have our original cluster in blue. Usually in blue-green, the blue is the original, and the green is the next version or what you're upgrading to. And normally, blue-green is not used for databases. It's more something you use it for like a version upgrade in a microservice architecture. However, most services do provide a blue-green upgrade. I think AWS do that in their managed service. They'll do a blue-green upgrade. And there's a really good reason for it. It's the safest. Absolutely, hands down, the safest way to do an upgrade. However, there's a cost. And the cost is the cost. Okay? It's double, if not more, for a really long period of time. How it works is you have this certain intersection where all the write information is going to go in and spread out evenly, like not evenly, but duplicated, like a T, to the OpenSearch cluster and to the Elasticsearch cluster. So the same data is duplicated to both, and you have duplication, which is wonderful, right? The good thing is you could also have this OpenSearch cluster running on completely different hardware. So you're not coupled to like what's going on the left. It doesn't have to be apples to apples. And in our case, we did want to upgrade. And when we were planning out, we thought we'll put Graviton instances on the right here in the green cluster while we're running Intel on the left. We might even upgrade the Java version, who knows? And some engineers would say, wait, we can't benchmark that. Like, how do you know what made it better? Was it Graviton? Was it moving to OpenSearch? And honestly, it doesn't really matter because you want to test like the whole thing, how it was, and where you've reached, and we're going to be on Graviton because of the cost. So what's the point in having your POC run for months and months trying to figure out which part of that actually made the difference? So we wanted to evaluate the whole architecture versus the new one. So once you're writing everything, by the way, writing meaning deletions and updates, of course, all going to that T and affecting both clusters simultaneously. You do that for a while. And when you're doing log analytics, it's usually the retention time. So if your retention is time-based and it's 7-day retention on this cluster, then the data after 7 days is completely new, which means you have to run this for 7 days. Okay, 7 days of data going to both. So it's double the cost for 7 days. On big clusters, that's thousands and thousands of dollars, if not more. Your read is only going to the blue. Okay, that's how blue-green works. You have the read only going to 1. Any questions on that? Just so far, it's rather okay. Then, after 7 days, data is identical in both, and you can switch the reads to the green. All right, and now you can test the read path. And it's very important to know that those are different. You can't just switch it and then kill the blue cluster. That would be a very bad idea. You'd want to leave it there for a while. You want to test and see how the reads are performing. You want to see, for example, the contexts that I was talking about. You want to see that there aren't any other thresholds that are suddenly being breached. And you'd want to run it for about another week. It's an industry standard, week-to-week comparison. You'd want to see that everything's running smoothly. So even if you're not going to run it for a week, maybe like a few days, you're going to run it for 7 to 14 days duplication. And if anything goes wrong, then you could switch immediately back, right? So if that's the best point of blue-green. If money is not an option, which today is not exactly the discourse, then you can just have these two clusters up when everything's ready, and you can see the read is also being done perfectly on the green. And I didn't talk about it, but you're also doing snapshots from the green, so you have your S3 costs also going up. Everything's good, you switch over, and if anything goes wrong in the near future, you switch right back, fix it, and then switch again. At LogzIO, we've done this in a previous upgrade that we had from Elasticsearch 5 to 6. it could cause, in one event where we just kept having issues with our green, moved back to the blue, issues with the green, moved back to the blue. It went on for about a month. The costs were tens of thousands, if not more. I'm pretty sure there were more, but not familiar with the exact numbers. So I don't recommend it. If you trust your upgrade path, you shouldn't be doing this, in my opinion. It's really a matter of trusting the new software. If you tested it correctly, if you looked at the things, at all the breaking changes, and you're sure and certain of yourself, I don't see a reason to do this unless it's very, very, very crucial that you're able to switch back. The in place. In place is, there's two different ways in the documentation to do in place. One is a rolling in place, and the other is a full cluster in place. If you're doing real-time analytics, you can't have full cluster in place because you're going to restart your cluster. It's going to stop for a while. And I can't tell you how long that while is. So if anybody asks me, well, how long is it going to take? Maybe 10 minutes? Is it minutes? Maybe. Maybe it's an hour. If something goes wrong and there's no re-election of the manager node, there could be issues in a restart. So I don't really like having that as a plan. Here's the plan, we'll restart it. Logs won't be ingested for a while. Alerting on live data, You don't want alerting to delay minutes. So if we're talking 10 minutes, that's pretty bad. That's why it's recommended to do a rolling in place upgrade, which means you install OpenSearch on the node while it's running, and then you restart it. And you do that again and again. The plan was to start from the data nodes, that's where all the shards are, and then move up to the coordinator nodes and the cluster manager nodes. The coordinator nodes, the terminology here in Elasticsearch and OpenSearch is a bit different. I'm using the OpenSearch terminology, but coordinator nodes were sometimes called client nodes as well. They're getting all the traffic, okay? Interesting thing to point out here is you can't change the hardware. You're doing it in place. So you're doing this whole rolling restart in place, and it's really on the same machine. And the other thing you might notice is there's actually no way to go back. Like midway, you even started one. Just one of them is restarted, and now there's an issue. There's nothing you can do. You're kind of stuck there. You have to either just push on through and fix the problem, or deal with shutting down that node and doing some recovery, which is very unpleasant. So in terms of revertibility, this is very unsafe. But in terms of cost, it's the best. It's pretty fast. In a matter of hours, you're totally done. There's code that'll help you do it. There's the OpenSearch upgrade tool. It's open source. You just download it, and it will copy all your config from the Elasticsearch part and change it to fit the OpenSearch. Then it'll do the restart. There's even a rolling upgrade lab, so you can test it and see how it works. There's a lot of tools to help you out with this. However, the risk is huge. Like no one would hear it. If I ever mentioned it, they were like, no, you're not doing, this is you can't even consider this in a production cluster with customers in many cases. However, if your data is not real time and you're not worried about that, I wouldn't mind doing like a restart in place. It's not that bad. I have a snapshot, if you're not worried about the real time aspect of things. I'm clicking this, but it's not quite. Okay. At LogzIO, we wanted to kind of balance things out. So you have the cost, you have the risk, and of course the speed of ingesting all this data and having the queries work at real time. In order to do so, we also wanted to address underneath the cost issue, we wanted to change the hardware. It's very important to try and upgrade things and be as cost efficient as possible. And when AWS was telling us you can save up to 40% on these Graviton instance types, like, of course we're going to move to that. It doesn't make any sense to stay on Intel in that case. So I'm going to talk about the method we used, and couldn't find it in documentation. Just called it the drain method, because that's what people were calling it around the office. Just do the drain, In order to explain how the method works, I'll talk about just a few things that are how the data moves. That's the important part, right? And what we do is we use the cluster settings and we use the allocation settings to say that node is excluded. And when you do this, the data is, wow, that was a bit too fast. Hold on, there. Then the data is drained from it. All the shards move out. And you can control the speed that this is done by the recovery bytes, max bytes per second. There. It's usually like 150 megabytes per second. It's kind of okay. And that means that's how fast just the network speed is going to be transferring that data to the other nodes. You could also do inclusion. So you can say these two data nodes are the only ones that shards should be on at any given moment. Once you do that, all the shards are moved over to those nodes. And this is really important because if there's a new index created at this time, it's only going to be on those two. Okay? And vice versa, when you do an exclusion, a new index is not on the excluded. Okay, so that's basically how you do exclusion and inclusion in Elasticsearch and in OpenSearch. I'm going to go over each stage. We're going to start with the data nodes and then move on to the cluster manager nodes. First thing we did is we'll do include for all the Elasticsearch instances. Add within the cluster data nodes that are running OpenSearch. It works. They just join the cluster and everything's fine. It's amazing. And we exclude them. That's very important. So at the start of everything, there's no difference. Data is going into the Elasticsearch side. The manager nodes, they know about the OpenSearch nodes, but they don't care. They're OK with that. And then at a certain moment, we see that everything's up and running, and it's time to then change, just swap the include, exclude. Hold on. There. So we swap the include and exclude. And when we do that, all the shards start moving over into the OpenSearch nodes all at once, which is kind of scary first time we did it, but it works. It's moving at a rate of about 150 megabytes per second when we usually start. And you could make it faster. Wow, hold on. This is a very sensitive clicker. Your max bytes per second, you could set it to like 300 megabytes per second, and then it's going to go faster, which might be something you want. However, this one time, we were doing an upgrade, and we had this nice little bash script running and showing us the percent of upgraded, of where the upgrade, the drain process, where it's reached. It was kind of stuck around 80-something, 85%. And so I got the on-call, and I'm like, what's going on with the upgrade? And he just kept lowering it and lowering it and lowering it, the max bytes from 300. He saw something was troubling the ingestion. So he just lowered it and lowered it and lowered it and lowered it. He got to like 10. I said, well, what's going on? And I said, you know what, let's just move it to 0. Let's just stop it. Oh, stop the event. Don't do this. Don't put it on 0, because when we did that, it actually, and it's now, thanks to our discovery of this, it's now documented in OpenSearch, that when you set it to 0, you cancel the rate limiting. No rate limiting. So it went from 85% to 100% within like 2 minutes. And then we were done with the upgrade. It was actually lucky that this bug existed. So ingestion went right back in and everything was fine. But we discovered this kind of the hard way. 0 means no rate limiting. It means 100%, like 1,000,000 megabytes per second if you can. I think it went up to 1 gig, about 1 gig per second, kind of transferring between the nodes. It's kind of, I bet someone at Amazon was really happy about that. Let's use this instead of the clicker. OK. Once that is done, you could already remove those old nodes, because there's 0 shards on them and nobody cares, and just reset the inclusion to null just so it's cleaned up. It's always a good thing to keep your cluster settings clean. And we're moving on to the coordinator nodes. Coordinator nodes are getting all the traffic, all the queries, all the data is going through there. But they don't have any data on them. So they're kind of just like a client node. There's a DNS record pointing to a load balancer. The load balancer is going to decide which one of those nodes is going to take the data or the query and perform it. So in order to do the upgrade, we're adding a new load balancer and some more coordinating nodes, and these ones are OpenSearch. But no data is reaching them, as you can see, because the DNS record is pointing to the old load balancer. And then the next step is really simple. Just change the DNS record. You override it. And once you've overridden it, some of the traffic is going to go to the new load balancer, and some is still going to go to the old one. But there's TTL on that, so it's fine. Just wait until everything is going definitely to the new load balancer and going through the new coordinating nodes. And at this stage, you're almost there. Like pretty much everything is done. The only thing that's left is the manager nodes, which are holding the state. And to be honest, usually if you kind of think, now we're done, it's fine, we'll just switch those. But for me, and I'm managing clusters for a while, this is the riskiest part. Touching the cluster manager nodes is really, really difficult to do. So let's talk about that just for a bit. The plan was just add new ones and remove the old, because they don't hold data, traffic's not really going through them. However, there's only one node that matters here, and it's the elected one. So the reason there's 3 is because of, well, you have to have at least 2 by default. And there used to be an issue, I think in Elasticsearch 7, I don't remember the version, they got rid of this problem with split brain that could happen. But we still kind of, we don't want to test our luck with split brain, so we have 3 or 5. And we even have them in different availability zones just for the, just in case. So if that elected node dies for some reason, then another one's going to be elected. In order to do the upgrade, we're going to add 3 more. And this is already an issue because that's an even number. And anybody who knows anything about split brain, you know you don't want an even number. It could happen once we have 6 up there, but it's a really short amount of time. So we enabled it. And then we're removing them one by one, the old nodes. And we're moving the elected one last. And then this is the part where you just sit there in front of your monitor looking to see if everything's OK. Of course, before automation. There is no elected manager node at this point, and the cluster is kind of in limbo. They're doing a re-election. And this re-election process takes a short amount of time. And if it's taking even a minute, then I recommend like forcing a certain node to be the elected. You can do that. There's an API for that. And that's it, and you're done. The cluster is now fully OpenSearch, and it's running. In terms of any of the microservices, like we said earlier, it's been prepared. So they're forward compatible with OpenSearch, and they have no problem with the new cluster. Really, at this point, everything was smooth, and we could see that we had done this like a few times for small clusters, and we trusted that we could do this in bigger clusters, and then eventually we started automating part of it. However, I didn't talk at all about risk. And because until now, it kind of looked like in place with extra steps, and a little bit more expensive because we're adding some nodes and it's simultaneous. The risk is something we had to discuss. My architect was telling me there's no way I'm doing this, if there's no way to revert midway, if there's no plan, no approval. So we thought what we could do, we thought about blue-green because it's the safest way to go, and we kind of built on it a hybrid solution. We create a really small, quarter of the size, maybe even smaller, Elasticsearch cluster running version 6. And we have these backup plug engines. They're another consumer group from the same topic. They're going to grab the same data, and they're going to put it inside this backup cluster. And we create it just before we're going to do the upgrade. It's only there for that period of time that we're doing the drain, and sometimes for a little bit longer, but we're talking hours. Once the data is flowing in, we'll do a snapshot, okay? Because we started backing up at T0, time 0, and then we're going to do a snapshot of the data that's currently there. So in the event that we have a problem, we'll be able to get all that older data. And if the upgrade goes smoothly, it's OpenSearch, and we're done. However, if we want, we could keep the backup cluster there for a while. If there's a specific use case some customer has, and it's their dedicated cluster, we may keep the backup there for a bit test out their specific behavior on the cluster and then move forwards. But normally, this is where we kind of just remove the backup. The difference between blue-green is that the backup is always the same cluster in the same availability zone. We just, keep it up there as long as the drain is happening and then kill it at the end. If anything goes wrong, you can't read and you can't write, which is really bad. So we just move the read over. And at this point, a lot of the data is not there. So if you're the customer and you're trying to search over the last day, you might see data of the last few hours and then nothing, which is alarming. And then you get a phone call. But it's OK for real-time, for the really highest profile real-time uses, because if you're doing alerting, it's usually the first minutes. If you're querying data and it's important because there's a bug, it's usually the last hour, the last 2 or 3 hours, tops. That's where a majority of the queries are sending their data to, requiring data from. So it's OK to have it. Not great, but it's OK to have this kind of buffer. And then we'll increase the cluster size, just make it 4 times the size, and restore the data from S3. At this point, it takes maybe an hour, and then all the data's there, maybe longer if it was a massive cluster. But the customers are OK because they've had their real-time data online the whole time throughout the process. And eventually, they get the data that's backfilled from historic stuff. And that's the risk management. We never, I need to knock on wood now. OK, never mind. It never happened to us that we had to use the backup cluster so far. We had the plan. We tested it a few times, but we never actually used it. Even in one event, like I described earlier, where there was some issues, it's preferable to push on through. If you've decided to upgrade to OpenSearch, just upgrade to OpenSearch. If you're going to roll back, you're going to be in limbo and going back and forth for a while. And it's not recommended to be in that situation. We decided we're just going to push on through. So just to summarize this type of upgrade, it's riskier than the blue-green, OK? But it's about 1/10 the price. It could be even cheaper if you're doing things pretty quickly on a small cluster. And another thing is that when you have both systems up at the same time, your blue and green, you have to have your developers writing features over those clusters be aware of both OpenSearch and Elasticsearch for the whole time. So for weeks, and if you're doing upgrades throughout, let's say, a month or two, when you're doing these upgrades on all these clusters, dozens of them globally, all the pull requests have to be compatible to both types. And your test environment, you have to also make that compatible for both types. Otherwise, it's going to be very hard to manage. So you're slowing down your production, which is something nobody wants to hear, like the VP R&D. Oh, we're going to make everything double, because you have to develop for 2 different architectures. Another thing you may have noticed is that the speed, it's not as fast as in place, but it's close. It's like a close second. It'll take a few hours on a really big cluster, and it depends how fast you can move the data. The more data on the node, the longer it's going to take. It's a simple calculation with the max bytes per second. Just multiply it, and it's kind of in the ballpark. The 99th percent, of course, takes the longest. And sorry, I lost my trail of thought. So once you've done all that transfer of the data, it's pretty quick. However, it does take longer, much longer than in place. It's like, in terms of the scaling factor, it's like maybe 4 or 5 hours longer. There's another way that I heard to do this upgrade that's kind of fast. And it is almost blue-green, but it's called the snapshot method. The snapshot method is when you take all the data, you've snapshotted it, and you restore it to the new cluster. So it's doing blue-green, but faster. However, the cost of that can be really high. If your cluster is really big, then you're bringing all that data from S3. So the network costs are there. And that's it about the drain method, and we're just going to summarize. So blue-green, fully revertible, instantaneous. You can replace the hardware as well. but it's really slow. And having both those up at the same time is also dangerous, which is why I wrote complexity. It grows over time. And the cost is immense. In place, on the other hand, is faster, but no rolling back and no hardware upgrade. And drain would be somewhere in the middle. The drain method gives you this full revertibility, but it's not as fast. On the other hand, it can replace the hardware, which is really great. We've managed to see that when we're replacing the hardware, it also reduces the cost considerably. The new instance types were so strong that we could just ingest the data much faster on them, so the process was even faster. So it's also cheaper, and also it's faster than the blue-green. The cost is higher than the in-place, and in terms of the upgrade process, this is probably the worst part about the drain, is it's really complex. So when I was explaining in place, it's like that. Talking about blue-green is rather simple to understand, but then when you go into this drain, you have to think about all these different factors. So it's a matter of managing your risk, managing how you want the cost to go, and understanding the rollback. So if your team is fully understanding all these APIs, it makes sense to work with something like the drain process or something that's similar. And that's my talk. So if you have any questions, this is a good time. And if you want to scan and DM me on LinkedIn, then that's my LinkedIn barcode, QR code, yeah. Any questions about OpenSearch in general or the upgrade?
Yeah, just a quick question on
Sure.
When the drain is happening, what happens to live traffic?
Live traffic, it's going to, it's still going to the original node where the data is. The drain is only affecting the transfer. It's just affecting the transfer of the data, but the cluster manager nodes, they still know where it is at that time. So there's a new shard opening, and then it's doing a reroute, okay? So until that reroute is complete, it's still there. And if it's still writing into a segment on that shard, then it's still being written there. And only when that new shard is up, it's going to transfer the last one, and it'll be written to there.
Okay, one more. Couldn't quite understand why we couldn't do rolling drain. I saw for the drain method, you bring all the new search nodes instead of one at a time. Great
question. Maybe it would have been safer to drain one at a time.
Also save you cost.
It's a cost, and also it's a network. Network costs are kind of low when you're doing it in the cluster, but because they're in the same availability zone. If they're not in the same availability zone, then it's going to cost a lot more. It's going to be it'll be n squared, because each shard is going to go possibly to that new node, and then again to the next node, and then so you're going to have this situation where shards are moving more than once.
So you can't do one-to-one map with my old Elastic node goes to this new OpenSearch node.
You can do that. It would be very difficult. You'd have to write a script where you say, give me a list of all the shards on this node, and then use a reroute API, which you could do, and then scroll and have all those calls and say each one of these shards move to this specific node. That would be possible, and not sure you get much out of it though.
I mean, you save cost because you don't need a full set of data nodes, right? You do it in rolling base, and it's revertible. You can just go back if you want to.
Actually, you can't. If you have an index that's accidentally opened on that new node, you can't go back. So you're kind of stuck because it has the new version. So in some cases, it makes sense. We did consider this at the time, but it wasn't it was so hard to make that script kind of work flawlessly, especially since new data could be coming in. And when you just start up all the nodes, it works. So there's not much of an issue.
Got it. Okay, one last question.
Sure.
From what you just said towards the end, I think I understood as doing this draining locally is faster, cheaper than doing it from the snapshot from S3. Is that so? If you had to just get most of the data from S3 and then get some of the data from the local node,
Much
which one? My intuition is the S3 method is faster, and cheaper?
The drain is faster than S3. You're moving the shards as the cluster is moving along. It's definitely faster. The problem is that when you do a drain, I think the cluster is going to be balancing things out much better because it takes a little bit of time, so at least the load's going to be balanced. Whereas if you pull from S3, there's a good chance it won't quite get balanced out the way you want. But again, it depends on how you're using your data. It's a model that I've heard people use. Again, less documented, but the snapshot method does work. Yeah. Yeah. So the question is like, when I described the drain method, I didn't talk at all about index versions and how did so they didn't change actually. In preparation, you have to upgrade your index version by re-indexing. So all our indexes were on version 6. And then once we've done the drain, they're still on version 6. We didn't upgrade them. And right now, like as we speak, at this moment, we're doing a re-indexing of all our data to version 1 of OpenSearch.
Separate from
Yeah. Yes, it's separated. So everything's being upgraded as we speak at LogzIO to version 1.2 point something. And we're going to do an upgrade to version 2 of OpenSearch. I think tomorrow version 2.7 is coming out, so looking forward to it. Yep. All right. Thank you very much. I'm here in the conference for longer, so if you have any other questions, feel free.